Welcome you to the SD online classes. This is class 10 MBAC chapter 3 physics. Name of the chapter is electricity. The page number is 70 in your textbook. The topic is electric current. Okay, in the name of the chapter is electricity and the topic here is electric current. Before this we have done electric potential and the numericals based on them in the second video. This is the third lecture. Now what we do here is that what is electric current we will try to define. Okay, the flow of charge through a conductor is called electric current. Okay, this is what I said. The flow of charge through a conductor means anything inside which charge can flow. It can be metal, it can be any other also, is called electric current. Electric current is also defined like this. Electric current is the rate of flow of charge. That means charge is important to understand what is current. That is why in the first video we were introducing the charge. Charge is what? The electrons. Okay, it can be positive charge also and negative charge. Mainly we will be talking about electron when we are talking about electric current. Now the flow of positive charge is called electric current. Earlier we did not knew that. Earlier till 1890 people did not knew that the electron was not discovered, so that is why they were making the electric current should flow from positive sides to negative. Of course it is true even now, but what is difference is that electric charge is responsible because the electrons are flowing from negative side to the positive side. Okay, and in its opposite way the conventional current that we call current flows in the opposite of the flow of the electron. Actually there is nothing like flow of current in real. Actually there is flow of electrons. The opposite of the flow of current is electron is known as flow of current. Okay, so how if the flow of current is very fast? Rate means its fastness, how speed it is flowing. If that is very fast we call high current. If that is very slowly traveling we will say that the current is less. So we define it like this: I is equal to Q by T. Remember Q is the symbol for charge. So I will be, look at the definition, is important. I will be more if Q is more. Charge is more, current will be more. If the flow of charge takes more time in the denominator, more time, then charge electric current will be less. If it takes very less time to flow, the current will be high. That means it is just like speed. Speed is distance by time. Just like that, current is charge by time. If that charge takes very long to flow, very long time to flow, means lot of time to flow, then you will say that current cannot be that high. Okay, it depends on the time also with which it takes to flow. Its speed of the charge, it flows. Okay, so this is that. Now SI unit is what? SI unit of current is coulomb per second. Okay, coulomb, C capital, seconds time, or another name is ampere. In symbolic form we write A. This is the unit. In place of coulomb per second we say ampere. Okay, this is the unit of current. Okay, and what is 1 ampere? Just like 1 volt was defined, 1 ampere is also defined. Okay, what is 1 ampere? When this will be 1, whenever this is 1 and this is 1, we say there is 1 ampere. Let us define it just like that 1 volt. Okay, it is important question. This is the definition of 1 ampere. What is this? The current flowing through a conductor is 1 ampere, is said to be 1 ampere. This will be 1 ampere when 1 coulomb of charge is flowing through a conductor in 1 second. Time it takes 1 second, and you make the charge 1 coulomb flow for 1 second, then you can say in that condition it is 1 ampere current. Okay, in short we can write 1 CS. C by S means this coulomb per second. Okay, what is 1 ampere? From here look at again. What is 1 ampere? Whenever charge is 1, whenever the time is 1 at the same time. For 1 second if you make 1 coulomb of charge to flow, then you can say that 1 ampere current is flowing. Very simple. Okay, now another thing is that what is that which measures your current? Current is measured in what? Current is measured, this is important, by using what? Ammeter. Ammeter is just like voltmeter, another box which is there in the lab. In physics lab you can see a small box will be there, where in the textbook also it is there. In page number 70 you can see on the right side, bottom right side, there is ampere sign, A sign, which looks somewhat like this. Milliampere may be there, sometime microampere also there, A is also there. That means that is something to measure your current. Okay, so this is about current. This topic next is direction of electric current. Which direction the current should flow? Okay, its direction is from positive to the negative side. And earlier till 1890 the electron was not discovered, but current was there. Okay, current, the people knew what is current, so they were not able to know exactly the reason of that current behind is electron flow. So before that they used to say this direction to that direction is flowing, fine, absolutely correct. But after the invention of the discovery of the electron, I have already told you in this video, that was established that it is the opposite of the flow of the electron, current is there. So how do we write this? Let us write. So this is the one, the direction of flow of electron is opposite to that of the conventional current. Conventional current is not a real thing, remember. Conventional current is something, because why it is conventional? Because it was very earlier said that current's direction. So later on we found flow of electron is the real thing. And if the flow of okay, this is electric circuit. What is electric circuit? Let's try to understand. Electric circuit is that when you have a electric current and it has to pass through some wires or any conductor, any path. If it is passing from one place to the other, one terminal to the other terminal, that path between which it passes through the wire or a conductor, that path is called electric circuit. Okay, there are two types of electric circuits. The first one is closed circuit, and the second one is open circuit. Okay, a closed circuit is the one where all the components of the circuit are joined to one another. There is no broken place. Okay, here all the components are of the circuit, of course, are joined to one another. Second one is open circuit. This was closed circuit, this is open circuit. You can see in your textbook, page number is 71, there is diagram also given, open and closed circuit together, you can understand there. Open circuit is there where there is flow of current having some breakage at some point. Okay, it has breaks at some point, means somewhere the wire is broken. Okay, some point, such that no current can flow there. No current flows through the component. Component means it may be a bulb, it may be a resistor, whatever it is. Okay, and in the diagram you can look at there and understand that there is a circuit where open and closed both are shown in the diagram. Let us just try to make it. This is the bulb here going here. This is the symbol of switch. Okay, and this is A means ammeter. You have to be used to with this type of diagrams because we may be drawing more and more later on. What is this? This is a battery, plus minus, two batteries, plus minus. First battery is this one, connect second battery. This is the second battery, plus minus. Third battery, second and third is also connected. Third battery going out here. So there are how many batteries? Battery has how many cells here? 3 cells. Okay, this side is plus, longer one, long one is plus, smaller one is. So this is wire, conducting wire, otherwise current will not flow, conducting wire. Here we try to measure what is the potential or voltage. Potential or voltage is same, potential difference and voltage is same. Okay, this is the bulb. Now current will flow from this side like this. It will go here, inside it will glow, and if this is off, okay, broken means off, this is called open circuit, right? If you put this down on, that will be closed circuit. This is open. Okay, if the same thing, if it is like this, this is connected here, if it is like this, okay, so then here it is closed circuit. This may be kept it here to measure the voltage current going this side. Okay, roughly I have shown you that this is the closed circuit, this is the open circuit. Understand, in the open circuit it is like switch off. Okay, whenever you switch off your bulb, that means what, you are breaking the circuit. But in the inside of that switch there is what, it has disconnection, so that's open circuit. When you close circuit means you are switching on the switch. In your home also it is like that, it is working like this is a switch, this is a switch, this is a very clear understanding of a switch, off, on. Okay, that is about open circuit and closed circuit. Okay, in the open the current cannot flow because it has not completed the circuit. Okay, so that is all. Thank you, and in the next we'll do important one, that is Ohm's law. Okay, thanks for it.